Hi everyone, welcome to UMA's Smart Building Showcase. What we're going to do today is going to quickly walk around the building, show you some of the sensors and the technologies that we've got installed and how we use them. And then what we'll do is we'll be able to overlay some of the things in the platform around it so you're seeing it side by side. It's an instructional video really to help you understand the capabilities of the platform today. So we're going to start out in the reception and we're just going to walk our way through the building. So first thing we're going to do, when we enter the building, we've got the ability to use our wayfinding kiosk. So you can walk up to this, it's a WebEx board, it's got all the floor map on it, and it's got environmental data that is coming out of the platform. So it's telling us what the occupancy, what the air quality, what the temperature's like inside our space. So let's say I haven't booked a desk or I haven't booked a space for the visit that I'm coming in at. This is perfect for that. So I can come along and I can see that there's a desk free. I can just go ahead and book that, and I can book it and click next. I'm going to book it anonymously. Sorry, I'm not going to book it anonymously. So we can type in. Now, this allows us to search Active Directory. So it should find me now and click book. What this has done, it's now sent an email to my Outlook. It's in my calendar that I've booked that desk, and it's now booked and available for other people to use. It's also got things like date and time, temperature, and live occupancy should you want to look at that. You can flick between desks and room view to zone view. Now that zone view is going to give you the ability to look at a heat map. Now, in theory, if you've got sensors all over this map, the red, amber, green will come up, either no occupancy data in the blues, green to say it's quiet, orange moderate, busy red. Nice and quiet today in the office space. And then you can just flick back to desks and rooms, and you can reset the map, and it will just redo that. And again, you can zoom in as well and pinch and zoom on there too. If you want to edit the board, quite simply hit the padlock, put in the code, and you'll see all the different things that you can do. You can allow booking, full screen mode, you can drop it into light mode, you can also do your default views, even though you can flick between the two. So that's the UMA kiosk working on the WebEx board. You've noticed here as well what we've got is a Meraki MT40 power bar. What this is doing is it's monitoring how much electricity this is using in kilowatt hour. We're therefore able to take that data and overlay it onto our platform, and everything that we do in the platform then essentially shows the cost of what this board is costing us to run. Now, this also has automation built into it through my mesh. So what we can do is turn this off at a certain time and turn it back on at a certain time in the morning. So in this building, 7 o'clock tonight, this will automatically power this down, and it will then at 7 in the morning automatically power it back up. So if we come and look at some of the other things that we do around power management. So this is the electricity board for K-Mill, so Innovation House. It covers all 4 floors in the entrance vestibule. It also looks after the boiler room. So in here we have a big boiler room that covers all the central heating. You can see here that we've got a 3-phase CT clamp connected to the mains board. This is monitoring the pulses running through those cables, and it is providing us with a amp usage. We then take that amp usage and convert it into kilowatt hours. So it allows us to understand what each of these areas in the electricity cupboard is using essentially. And we've also got a tiny little temperature thermometer on it, which tells us on the main cable if there's any heat or anything sort of heating up over a period of time, because it can happen, and if something is causing a problem, then the electricity is monitored via that. We've also got a single phase one. Now this is sectioned off, so this does the whole area. This is the boiler itself. So it's the main boiler, and it's a single phase on a single circuit. So this is monitoring again the same thing. So here we're measuring how much electricity is being used in the reception. Here we're measuring how much electricity is being used on the boiler itself. And this is how it connects to the gateway, which is a LoRaWAN MileSite sensor. So this is the CT clamp that we use from MileSite. We've also got other technologies in the bathroom, for instance, non-intrusive sensors that count. We've got the ability to see whether the bathroom is full or not. So up in the top corner there, we've got a very small PIR sensor that acts as an occupancy in private settings. So you'll be able to see there that that is on a ball socket and points down and tells us on the dashboard whether the bathrooms are occupied. So again, it's just another use case on how you can see the different sensors work across the building. So then as we come through into the main office, we have got our floor occupancy. So imagine this in multiple offices, lots of floors, different levels, and you want to get whole building occupancy. So sometimes things like desk booking, desk sensors, they might not paint a true picture of who's been built into the office that day. So using a sensor that counts building occupancy is the best way and the most accurate way to get that data. So we use a MileSite device here. This is the VS131. It does line count, so it's a time of flight sensor. What that means is you can walk through the building and there's a virtual line here that allows you to cross back and forth, and it counts people in. It is very accurate, and when we get into the building, I'll show you some of the way that works. These can be configured in different ways. You've got things like line crossing, you've got dwell time, you've got gate analysis where it will tell you, which way people are walking. It can be configured in lots of different ways, and that sensor is one of the most powerful ones we've seen, and it's definitely the one that we recommend for this type of solution. It also connects to multiple sensors, so you can stitch them together and put them in an entrance and exit. So if somebody comes in through one and leaves through the other, we're getting an accurate occupancy count. So then as we move through the building, we've also got the visitor management check-in. So this is using a neat frame. We have the ability to put this on any Android device. We've got a kiosk that you use, and we've also got things like the WebEx board, the Board Pro, and you can put that on here. And this is a standard check-in solution. So you can touch the screen to start. Have you been invited? Yes, I have. And then you would search to find your name. Have you been invited? No. It will ask you to fill in whether you're an employee or a visitor, and you can put your details in. That will then send a notification over to the host of your visit and tell them that they're here. That can be done via email, Microsoft Teams, WebEx Teams, or text message should you want to do that. Okay, so then what we've got is our kitchen area. In here, we've got a number of things going on. We've got radiator valves that monitor the temperature of the room and turn the heating up and down. We've got water leak detection, water pressure and water usage sensors. We've also got a smart plug that gives us the ability to see how the utensils are being used. So if you come in, I'll show you those sensors. So firstly, we've got the two types of sensor above. So this is very similar to the sensor that we've got in reception, but it's set up in a different way. It's actually set up so the floor space is in use, and you can kind of see who's in here and how long people dwell in a single space. We've then got the line crosser as well, which just allows you to have very straightforward passive in and out, and you can see that up there as well. We definitely recommend the MileSite product for this because it is far more accurate than what it shows there. Now if we go to here, you can see the MileSite TRV. This is linked to the platform, and we have got, using UMA Mesh, the ability to make that radiator valve control the heating based on the temperature that comes from some of the sensors we've got in the building. Now over to your right, you will also see we've got a smart plug, again from MileSite. What we've got plugged in there is the water dispenser, the kettle, and the toaster. So all the usage coming from those appliances is being monitored in kilowatt hour. That allows us again to look at the cost that might be coming from those devices. And then finally in here what we've got is a water leak detection sensor from Quantify on the LoRaWAN framework. What's different about this one is it isn't physically welded into the sensor. It is a clamp that sits around the pipe, meaning it's really easy to deploy and as accurate as a sort of welded into one which monitors the flow. Use cases here are tenfold. You've got the ability to monitor temperature, flow. Again, that allows you to see whether you've got any leaks in the system. You can monitor the litre usage, so how much water you're using. And again, we can cross-reference that with your tariff for your water, so you can work out how much you're actually using. It alerts you for things like water leaks, but also when you work on flow and temperature, there's a formula that's created to showcase Legionnaires. So if you have got a potential buildup of Legionnaires in a building, then this would start to notify you based on that through the platform. What normally happens is in hospitals, in places that are looking for Legionnaire, they send people around with dipsticks to measure the flow and temperature of the water and then manually work out what the risk of Legionnaires is. That takes that away. So operationally, it gives you better cost, all for a very small price tag to connect that to the device. So this is our first meeting room. So as we go in here, this is a Cisco WebEx room kit. What we've also got in here is a number of sensors and a number of pieces of technology that support the use of the platform. So in here, the first one is the WebEx device. This allows us to count occupancy in here. It allows us to monitor the temperature, humidity, the VOC, so the volatile organic compound, so this is air quality, not CO2, temperature, I've said temperature, sound, and also ambient noise. So when you turn that on, we use the camera, which provides the ability for us to people count. And it also connects in with the calendar, meaning that if we book this room, we can one button dial in here in either Microsoft mode or WebEx mode. So that's kind of what this does, and it gives you a whole room picture. We've also got a number of other things in here. So we've got the fall detection sensor. Now I know this isn't the right kind of space for us to be demoing this, but think hospitals, think bed monitoring, think toilets where someone might fall. You can utilize this device in that scenario. It's got some features in it. It doubles up as a fall detection sensor. It will also double up as a bed monitoring, bed occupancy, bed fall, with some new features that are constantly coming out. So even monitoring the respiratory rate of the person laying in the bed. So you can start to think about use cases in healthcare for this as well as other places. If somebody falls and it detects no respiratory rate, then that can be seen as a critical alarm that can be set from there. This is just a standard Meraki help button. So it's an IoT button. When we press that button, it will trigger an alert in the system and it will send a call for help. In this scenario, we've got it geared up to be a help function for a facilities manager in the building. And when that comes through, I will be able to show it you on my watch when the message actually lands. We may have actually turned messages off and gone for WebEx, but we'll double check that as we go through. So that's inside the room. So this one here is giving us all the environmental control, occupancy, help functionality from the button if there's a problem in the room, and also we've got the fall detection sensor from MileSite, which allows us to look at safety features in any kind of setting from there. And of course, on the outside of the room, we've got the Cisco Navigator panel running the UMA Book UI. So this is sits outside the room. It shows the calendar and all of the data that is, whether it's available, whether it isn't available. You can quickly book the room from outside. You can see all of the ESG metrics, you can see the occupancy, you can see the countdown on the meeting minutes. Now this is turned orange because nobody's actually triggered inside the room. It's saying it's booked, but it isn't showing any occupancy. So I'm going to walk in there now, and if we keep an eye on this panel, we should see that that changes to red, and it should pick up the occupancy once it's got me from there. So that's how quick that is. That is instantaneous, giving us occupancy. And if I stay in this room, we've got things like auto book and auto check-in, and also we've got the ability to keep, not release this room. Whereas if I didn't stay in here after a period of time, we could release the room back into production. So I'll come back out of there. As with the board outside, we've got the ability to book this for a period of time. And what we've also got is the ability to use your account. So again, search by name. This is not something that most of the competitors have within their product offering. It's usually just a service account that books this room. So if I click onto here and I click enter, and we look to just remove that, confirm the booking, that's now booked this meeting in Outlook, and you will be able to see on the up and coming meetings that it is here. Also in Vision, you'll be able to see the actual booking and the calendar, which I'll be showing. You should see now on the demo a copy of my Outlook and all of the other things that we're going to show. We've also got the Meraki camera. So this is a fisheye camera that does a whole view of the building and also acts up as a people count sensor. So we can use this to count how many people are in the office at any given time. And then as we start to move through the office, we have got a sensor here which does temperature, humidity, and CO2. So it's a combination sensor. The difference here is this one runs on the N-Ocean framework. So this is using a low-grade transmission protocol. These sensors themselves are powered by ambient light. They're not powered by battery. So therefore they are a big win in any kind of sustainability play, and they last for a long time because the batteries aren't in use. It's using the ambient light, not solar, ambient light on these panels, which makes it a really solid device for monitoring it. You probably need to give it about a week to bed in for it to be properly creating your kind of metrics in the right way, but it certainly does provide a great way of doing things. Now this runs off of a gateway. We do see a downside to some of the gateway based devices on the Ocean, because not only do you need a gateway, every 30 meters you would need to put a repeater for that gateway to bounce off of to connect to these sensors, and that's because they're low powered. They're not using a high range frequency like a LoRaWAN product. They're using a low powered frequency. So some of the things we can do to get around that is we've partnered with Cisco, and we can integrate the Cisco access points and turn them into a gateway. By putting this dongle into the gateway, into the access point, we essentially turn it into a gateway which it can talk to the sensors on. So the sensors that you would use in that scenario are desk sensors, PIR sensors in the room, which if you look up here, you will see some of the N-Ocean based sensors that are just PIR. So this middle one here would be something that you would put in the room. You can see again, it's powered by ambient light, not by a battery. But that would be essentially talking to the access point, and you would be able to piggyback off of the network to do that. Same with desk sensors. So over at the desks, we've got desk sensors underneath. So if I just pull this out, you will be able to see there's two sensors under there. There is a MileSight LoRaWAN sensor, and there's also a N-Ocean PressAct sensor. So again, we're showing different sensor technologies, but we are allowing you to choose based on what's right for your customer. So that's in there. Our light is controlled as well by the smart plug down here. So again, we've got smart plugs in all of the rooms. So we've got a smart plug in Maverick where everything's connected to that. So again, we now know how much energy the smart building is using. and we also know how much energy is being used by that lamp there. We've done it in the kitchen, so as you can see, as we're moving around, we're painting a picture of all the different touch points in here as to what we can do in this space. So the WebEx device as well, the Desk Pro can be used and configured into visitor management mode, but it also works as a drop down for hot desking, and we will count the occupancy off of here as well as temperature, humidity. So what are we doing about power management on this bank of desks here? So there's 3 desks, technology in there. Similar to what we've done outside, we've got multiple ways of doing this. We can use a MileSite smart plug to automate desk turn off, turn on, or we can use the MT40, or we can use desk power that has APIs in them to allow us to power desk sockets up and down based on usage. So in this scenario, we've got MT40 connected to this bank of desks, which allows us to power this down at 7 at night, power it back up 7 in the morning. So we're cutting electricity. So far, no electricity at night, everything's turned off in there, meeting rooms are turned off, devices are turned off, desks are turned off. And that's the same across these 2 banks of desks. So that's our energy that we're looking to cut from there. We've also got a number of room booking panels that are connected to different brands. So here we've got the booking panel connected to Yearlink, to the Neat pad, to the Pro DVX panel, and then we've also got a UI for our count app. So this is another interface that lets you count how many people have been in the building or who's in the building. So you can see there's 3 in the building today. That's me, Dan, and Johnny, who's holding the camera. So if I walk over here and I open this cupboard, we've also got an AMX panel here, which we use as a desk booking panel for my desk. Now, again, this is integrated with AMX. So we've got Crestron, AMX, Cisco, Yearlink, Neat, Pro DVX, and iPads, any Android device you can connect to. So this cupboard has got 2 different sensors in here. They are, again, energy monitoring sensors. We are using the Pressac N-Ocean protocol sensor, so it's connected to a gateway, and that's monitoring this office's electricity. So this isn't out in the hallway, this is what UMA's office is. This is our entire electricity feed. And we've also put a netbox clamp on there, which is another brand and another type of manufacturer that works on the LoRaWAN framework, which allows us to monitor how the differences are between them. Because what we want to do is make sure that we're providing a benchmark against the 2 different protocols to ensure that they're providing us with an accurate number. And these are, I would say, within kind of a 98% accuracy rate, which is enough for a kind of comparison area on that. We've also got a single phase Pressac sensor sat on there, which is monitoring the kitchen sockets. So again, we can monitor kitchen sockets from that single phase in there too. So we're starting to build a picture of devices, appliances, sensor technology that's been, brought into the platform, and we're building that picture up as we walk through the office to create this digital twin that we're aiming to do. We've also got Meraki here as well again. So this is the MT15. This one is quite powerful, has quite a lot of different things in it. It has the ability to also do vape detection as well. So from a college, school, public toilets where you don't want people to be vaping, that also works here as well, which is again another great selling point of the Meraki MT15. So as we kind of move this way, we've got a number of things going on up here. So we have a sensor above this desk, and there are 4 desks here. So what this does is it allows us to automate the building. So if, for instance, and I've not got it turned on in that mode at the moment, but I can talk about it a little bit. If, for instance, Dan and Johnny were sat here, that lighting will come on. If Dan and Johnny weren't there, that lighting bar there would turn off and this one would remain on if it saw occupancy here. Now, it can also count who's at each desk. So instead of having sensors underneath, you can have a sensor above that counts both of those areas and gives you actual occupancy. And what that shows is quite interesting, because if you look on this board over here right now, you can see what that camera is outputting and the field of view that it actually shows. You can see the frame rate, the codec, its streaming abilities. You can see me here moving around. Now, that is one view that the sensor can be in. That's what allows us to see who's at the desks and how long they're there. And it also triggers and provides us the ability to turn the lights on and off based on occupancy. So if we then, and I mentioned this before about the other view, if we look at the time of flight people counting sensor, and I was to swing over here, this is what you see at the entrance and exit. So I'm going to go walk out of there while you keep looking at this, and you can see what that does as I walk out of the building, and all of the infrared type technology that it has built into it. You'll see me walk through like this, and then you'll see me walk back through like this, and you can see that line following me. It's essentially working out which way I'm going. Now, you can also configure this to do what's called U-turns, so how many people go in and straight back out on a U-turn technologies. It is a very, very good application that allows you to get accuracy at its best. This is an Avacor board, so again, we're running on here our wayfinding map, and the ability for us to full screen this allows us to show what it looks like on an Avacor board. Resolution's a little bit better on here. It's because it's running from a PC, not from a web-based driver inside the device. As a curve point, when you're running something like this, you need to use a PC plugged into it. Onboard compute on screens isn't always strong enough to run the complexity and power of the mapping and the technology, so we always recommend an i3 minimum NUC with about 8 gig of RAM should do it, and that's a perfectly good specification for that. We've also got the neat bar here, so what this does is it counts occupancy in this area, so we have a very small kind of get-together area here. That neat bar is connected to Microsoft Teams, and we use it for some of our all hands and open space collaboration. Now, that also, like I say, counts occupancy in this area, and how that sort of all comes together. Also monitoring from above is another product called the Portal Beam by Contact.io. So this is another product that works wirelessly and counts occupancy. And again, it's covering a certain area, so it's giving us an understanding of what the occupancy is like on this floor here. Now, there are limitations to this platform. It runs on BLE, so again, Bluetooth isn't the best for this type of technology. We always recommend you go wired for any kind of people counting device that has video in it due to anything going wrong or connection issues. We do recommend you stick with a wired version of that. But it is available to use, and you can use it should you wish to. The good thing about that is it's also part of the Cisco Spaces product catalog, which means you can either use it in UMA natively via the Spaces connection that's coming, or how you see fit with other pieces of technology. Over here, we have got a smart lighting controller. So you've probably noticed by now that this building doesn't have any integrated BMS, it doesn't have any integrated HVAC. I've got really old radiators on the walls. So everything we've done is retrofitted into this building. So this is our standard lighting, and we've connected this controller. This is an 8-core controller, so we can have up to 8 different lighting frames into it. And we can then, using our UMA mesh platform, create a nice flow for turning lights on and off. So as I was showing you earlier on, if people aren't sat at that desk, we can turn this light and bank off. If somebody triggers our sensor on the way out, and there's no occupancy in here, we can shut everything off. So we're creating automation via the platform and all of the connected pieces of technologies that are in here. So over here we've got the 7-in-1 mile site sensor. So this one provides us with a bit more information and a nice visual display. CO2, temperature, humidity, TVOC, lighting looks, and it gives us a visual representation of the overall building kind of solution and ESG metrics. So that's the mile site sensor. Again, battery powered, lasts 5 years, and will sit there and visually work in a really nice way. We've also got the lighting scene here. So not only can we automate, we can override and create scenes for the mile site for the lights. So we can actually program these to do anything. They could be alarms, they could be, lighting control, it could be switching between HDMI ports if we were doing something along those lines. And then this is our next meeting room. So we've also got in here a number of things. So another Cisco device. So this is this is the Bar Pro, and this does the same as it does in Maverick. It provides us with all of the environmental data, occupancy, and the analytics of how this room's been used. But we've also got a number of other things in here as well. So we've got the 2 door sensors from 2 different brands. We have Meraki and MileSight. These will alert you if the door's been left open for a period of time, if the door opens at all, because it's a security aspect. We can provide a full set of analytics on how that's done. We see these in things like data centers, in private rooms, server rooms. They can be used for any kind of use case along there. Up at the top here, we've got a light lux sensor. So this is monitoring the light and whether we've got good lighting in the building, which also helps with people having the ability to work efficiently. If the lighting's good, they can be more productive, and it's not causing any issues with strain. And then all along here, we've got a range of Meraki sensors. So everything that I've talked about today out there, they're here as well. We've got water leak sensors, which have the end, which allows us, if they pick up moisture, it will send an alert. We've got the MT12, which is temperature. We've got the 14, which is TVOC. They're all in here as well, providing this room with a great kind of health score, if you like, of how the building has been used. So that's in here. Showing what we're doing with a smaller type meeting room. Again, we've got another navigator panel outside this room showcasing the platform, as well as a switch from Enocean. Pressing those switches does something very similar to the MileSight one, whereas it will allow you to kind of click and do what you're doing there. As we go around, you'll notice that each desk has got a QR code on it that allows you to book the desk, check into the desk, and to see who's got that booked. And again, if you kind of look down on the desk as well, we have a hardware device that can be used as well if you want to move those around as you would see fit. So that is pretty much all of the platform. Fully automated building. Everything powers down when not in use or triggered by occupancy. Everything powers up based on routines and schedules. You can use UMA to book. You can use visitor management. You've got intelligent lighting, power monitoring, water detection, energy usage. It's all in the platform. And it's done via what we call retrofit. There are 3 phases to the product. There is retrofit, which is us coming into a space and deploying sensors on top of the building as it is. We've got the deep refit, which is when a building is being essentially refurbed. So you're taking out the walls and moving things about. It means we can build some of this technology into the infrastructure. And then you've got the new build, which allows us to consult with and tell people how they want to do that. Now, there's one last thing I want to talk about, which is, well, what about those ones that you do connect into, and how do you connect into them? Well, we use a product in conjunction with UMA Mesh, our software connector tool. We use a product called the N-Ocean Smart Server. Now, what this device here does is it sits in the building and allows you to send messages in a protocol called BACnet from our product, from our sensors, to a BMS platform. So if you have got a BMS and you're not using things like TRVs, you're not using things like heaters or smart plugs, and you have a building management system, you can push that information from our platform to a BMS and make it do something for you. And that's done via this in conjunction with our software platform. These two devices here are the gateways I told you about. So you have the MileSite LoRaWAN gateway. So bit of information on this. In built-up areas, there's a 2-kilometer radius for connecting to a sensor. And in non-built-up areas, you can go up to 15 kilometers. And then this is the Presac N-Ocean one. So this is the one that if you're not using the gateway inside the access points, you will need to have one of these, if not one per floor, and then every 30 meters you need to put a repeater to boost the signal to that device. And if you remember, that's because it is low powered and it requires more of a signal, whereas LoRaWAN will run for kilometers in that area. Thanks, and I'll see you again soon.